Very good morning to all. So I am Dr.C.Senthilkumar, Associate Professor. Here I am here for radiation heat transfer explanation for the heat and mass transfer lecture series for the 6th semester mechanical engineering student. Let me see the topics now. It's a recall conduction, convection, and radiation. Radiation we will see now, and conduction is transfer of heat between the metals. Convection is transfer of heat from fluid to metal, and the medium for the conduction and convection are lattice vibration of free radicals, free molecules, electrons, and free electrons with fluid for the convection. So electromagnetic waves are the waves which does not have any particle which can travel in the vacuum also. So now let me see the topics for the discussion. Design thinking stages of radiation heat transfer, radiation heat transfer types, mechanism of radiation, Stefan Boltzmann constant, law of governing equation, and assessment. So design thinking stages, radiation heat transfer, empathize, define, ideate, and prototype and testing. So in case of empathize, we know that sunlight warming objects, heat radiation from fire or heating elements, and infrared heating and thermal cameras, which are all empathized and produced based on the thermal concept. When we define the problem, inefficient heat transfer in radiative environments has to be transferred. Need to improve temperature control or thermal management or thermal insulation. So it is being carried out in the scope of the sustainability. So ideate, brainstorming solutions and define solutions as the ideation, where we use reposition heat sources, optimize source emissivity in case of ideation design thinking. Whereas prototype and testing, we develop test heat shields, design radiative barriers, measure emitted and absorbed radiation. Coming to the concept of emission, emission is the process by which body emits thermal energy in the form of electromagnetic waves, which can travel even in the vacuum also. Example, heat emitted from the hot sun or furnace is the example of emission. Absorption, which occurs when surface receives and absorbs incident radiation and increasing the internal energy and temperature. Example, a black surface absorbing more solar radiation than a shiny surface. So the example again is a black surface. Okay. So the reflection is a process in which incident radiation bounces off a surface without being absorbed. Shiny and polished surface reflect more radiation. Example, aluminum foil reflecting radiant heat. And transmission occurs when radiation passes through a material without significant absorption. It depends on the material's transparency. Solar example, solar radiation passing through the glass window, which is the transmission, which we are seeing in the day-to-day life. So coming to the concept of radiation in this pictorial representation, when the wood is fired in the chamber of the house for cooling, heating purpose, warming purpose, the heat emitted by the fire which is coming and giving heat warm to the people sitting over on the sofa here in the cold room. So this is what the radiation. This radiation happens with the magnetic waves, electromagnetic waves, which can travel even in the vacuum also. That is what the important concept of radiation of electromagnetic waves. Coming to the concept of Stefan Boltzmann constant, a scientist who found a constant in case of radiating bodies, emitting bodies. It is fundamental physical constant used in radiation heat transfer. Relate the total thermal radiation emitted by black body to its observed temperature. The sigma value is 5.67 into 10 power minus 8 watts per meter squared Kelvin power 4. So here the black body is said to be the perfect radiator, and white body is said to be the perfect transmitter and insulator. And coming to the higher emissive comparison and lower emissive body comparison. So the emissivity does not, it is a dimensionless unit, and it's having the range of value 0 to 1. So 0.97 is the highest emissive body, it's a human skin. Black painted surface having the high emission value 0.95, and shiny stainless steel having the lower emissivity body, which is 0.1. So it is the chart explaining, this is the table explaining all the detail of high emissive and low emissive bodies. Coming to the governing law, like conduction, convection, and radiation. In case of convection, we had seen the governing law was Fourier law. In case of convection, governing law was Newton's law of cooling. Governing law for the radiation is Stefan Boltzmann law. This law states that the thermal radiation emitted by a surface is proportional for fourth power of its absolute temperature, Q equal to emission into Stefan Boltzmann constant into area into 10 T power 4, where sigma is Stefan Boltzmann constant already we had seen. The epsilon is the emissivity of the surface and Q is the rate of heat transfer. Area A is area, T is absolute temperature. So coming to the recall, radiation. Radiation heat transfer states that thermal radiation emitted by surface is proportional to the fourth power of the temperature. So these are the summary we have seen in this concept. And coming to the curiosity challenge, radiation becomes significant only at very high temperature. Why? So this is because the radiation, when it is high temperature, the electromagnetic wave can travel very faster rate. That is why it is significantly high. It is significant only very high temperature. Otherwise, the conduction plays very significant role. So these are the self-assessment questions. Let me see. First question, radiation heat transfer does not require solid medium, liquid medium, gas medium, metal medium. So they are asking does not require. So solid, liquid, gas has the radiation and metal medium does not require any um, radiation heat transfer because it has the conduction over it. So the second one is the law governing radiation heat transfer is Fourier, Newton, Stefan, Fick's law. Just before we have seen that is the Stefan Boltzmann law. So that is nothing but Q equal to um, epsilon sigma a t power 4. Okay. So thank you. This is the answer already we discussed. And coming to the reference, these are the references. And thank you very much. Thanks for listening and thank you.